Okay, I guess we're recording. All right, so let's talk about increasing, decreasing, and constant intervals for functions. Increasing, all that really means is the graph rises as x increases, or as x gets bigger. Let me just use more layman's term. Also, another way to think about it too, I'm going to put my calculus hat on because we should do that. Also, if you draw a tangent line, it should have a positive slope. So for example, do you guys know what tangent lines mean? Let's go back to some basics from geometry. If I drew a line like this and it touches once, do you guys remember what that line's called? It's called a tangent line. That's a tangent line. So a tangent line, let me write that more neatly. It's really sloppy. It's up. Oh yeah, of course. This is crazy. Why did I do that? That's silly of me. But what we do is first I'll erase the board. That's what a tangent line touches the curve once. So see how it's the circle there? So that circle just barely grazes. Sorry, that line barely grazes the circle. That's called a tangent. Which you guys, I think, did cover in geometry. Hopefully, I know that was during the pandemic. Actually, I don't know if you guys covered it because that was when we were doing 4 weeks of math this semester. So I don't know. Hopefully you did. But that's what a tangent line is. It just touches the curve once. So if I did that over here, if I drew a tangent line, now actually this will touch more than once. It will touch in other places, but for now it looks like it touches once. So that line is positive, right? So if you ever draw a line to a curve and it just grazes the graph and that line is positive, it's going to be increasing. We say it's an increasing because it's like a roller coaster, right? Like you're going up the roller coaster as you're going from left to right. As x is getting bigger, if the graph rises, we say it's increasing. Now, decreasing will be the opposite, obviously. So I call it a decreasing function. So in this case, what's happening, actually, I'm going to get a little smart here. In this case, the graph drops and will have a negative slope. It'll be a negative slope as x gets bigger. As x gets bigger, we're always going to look at what happens as x gets bigger. So we're always going to look at what happens to y as x gets bigger. And plus, if I drew a tangent line, so if I drew a line like right here, what's the slope of that orange line that's touching the curve? Is that negative or positive slope? Negative. That's how you can tell it's decreasing. If you drew a line tangent to the curve and its slope is negative, because that means that the graph is dropping. Increasing, decreasing is kind of the crux of first semester calculus. It's a big deal, especially tangent lines and slopes. It defines all calculus for the first semester. Of course, there's some mathematical things you'll learn and processes involving calculus, which we won't touch on in this class. But graphically speaking, we want to understand what increasing and decreasing means. And then lastly, constant. Constant means not changing. So y does not change. As x gets bigger. Hence why it's called constant, right? Also, the slope is 0, as it should be, because you have horizontal line. So it's just going to be horizontal lines. That's what's meant by constant. So again, increasing the graph rises, decreasing the graph drops, constant stays the same, no change. Hope that's intuitive. So let me give you a sample. I'm just going to totally make one up right now. Let's say I got something that looks like this. Okay. So clearly the graph is rising over here and rising over here. It's dropping over here. And there's no change here. So how many different intervals do I have right now? Would you say? How many different pieces of this graph? Like piecewise function. How many different pieces? Four, right? You have the first piece, the second piece, the third piece, the fourth piece, right? The first piece, I put a plus sign because if I were to draw a tangent line, it'd be positive. Also, think of like a roller coaster, right? Think you're like at an amusement park, and you're starting here. What's happening in roller coaster? Are you going up or down? Then you hit the peak, and then start yelling, and then you go down. And what happens in the third interval here? Flat, fully flat stays, and then what happens in the third? Rises again. So how are you going to write this? Let me label the axes, because that will help. Now I got to like really squint here. Make sure I label this correctly. -1, -2, -3, -4, -4. So it starts at -6, I think. That's 0, 1, 2, 3, 4, 5, 6. And it goes all the way up to what? 7, 8, 9, 10. Okay, I think I got it. So here's how you're going to write it. Actually, give me a sec here. Think about this. Oh, hey, Rich, how's it going? Sorry, I was in deep thought. Sorry, Rich. Didn't mean to ignore you. You know, the whole parentheses bracket thing is kind of debatable. I'm going to do this. We're going to assume open intervals. So I'm going to do this, and then I'll explain. There we go. Okay. So the first interval goes from -6 to 0. So when you state the intervals, you're stating the x coordinates. So yeah, there's a little confusion here. Let me put this in the notes. When you do all this stuff here, let's go black. State. There we go. So you gotta say the x coordinates for each interval when determining if the graph is increasing, decreasing, constant. Don't say the y. You always say the x. So this graph is clearly rising in this portion. What's the x coordinates for this interval? -6, 0. There we go. And then where's the other place where it's increasing? The fourth second, right? And where are the x coordinates for that? 6, 10. You never say the y coordinates. You always say the x coordinates. Sorry if I wasn't clear about that. I'm glad you were confused because some teachers kind of gloss over that and assume you guys know, but you don't. It's first learners, right? And then decreasing, where's the graph dropping? That's second. Where the x-coordinates go with that? It starts at 0 and ends at 2. And then lastly, where's the graph constant? Over here. Now, the y-coordinates -3, but I don't care about the y-coordinates the same. I want the x-coordinates the same. So from 3 to 6 is constant. Now, the part where I was kind of like, wasn't as deep thought, was whether I should use brackets or parentheses. It is debatable. Because if I put my calculus hat on, you definitely want to use parentheses. But if you're just thinking about it in terms of pre-calculus, I could see some validity for brackets. Personally, I think a lot of calculus teachers kind of just do the open intervals. So I'll just say state the open interval, so you don't have to worry about whether you put a bracket or parentheses. State the open interval means put parentheses. Because it is kind of, there are methods to kind of go back and forth as whether you should use brackets or parentheses for these intervals. I go back and forth myself, so we'll just avoid any ambiguity. We'll just do open intervals instead. So that's increasing, decreasing, constant. Sorry I spent a long time on that, but it kind of deserves its proper attention because it is a big part of calculus. I want to make sure at least you have a visual of what it means to be increasing, decreasing, and constant. Let's move on to the next page. Okay, so now we're going to do some practice, and then we'll talk about mins and maxes. We'll talk about audio and function. We'll do this. And the more I think about it, I don't want to do the second part of these notes. I think I'll save that as a video that you guys can watch. Because I think we kind of get to the point after the first 3 pages, and I'll give you guys a homework after that. Okay, so let's work on these here. Let's figure out what's increasing, decreasing. So I'm going to help you guys out. I'm going to label this first. We'll have increase, decrease, constant. Likewise here, increase, decrease, constant. And this is the beauty about Zoom. I'm going to highlight. Hold on, Gigi. Just give me a sec. All right. Yes, Gigi, go. What's your question? Oh, sorry. Still, sorry.
It's okay.
Yeah. Go ahead.
I was wondering for A, because of the arrows, would that mean that it begins at negative infinity?
Exactly.
And then that it goes to infinity?
Right, right. And let me make that a little more clear with the arrows. Yes, 100% correct. So, and I labeled, I color coded. Hopefully, you can see that green's positive, red's negative, and blue's neutral. Hopefully, yeah. Maybe that makes sense. Yeah, let me draw these arrows here. So yeah, you got an arrow here, arrow here, arrow here, here. There's a hole here, by the way, and it filled in right there. I think that's kind of important that we kind of, and I'll put like dots here as well, because they're kind of significant points. In fact, we call those critical points, which I'll explain on the next step. Okay, increasing, decreasing. Actually, I got this in Zoom. It's a video. All right, let's see here. Okay, so yeah, let's do it. Let's talk about it. So where is this going to be increasing? From what to what? Good. Perfect. Thank you, Estelle. That's outstanding. That's it. And then none for constant. It's never constant. Yeah, that's fully it because it's clearly rising. You go like a roller coaster. You're on the roller coaster right now. You hop on, go down the roller coaster. Then you hit the low point. Then as you go up the roller coaster, then down the roller coaster. Down the row. Because they're arrows, you got to put infinity or negative infinity, depending on whether they're coming from the left side or going towards the right side. Yeah, because there are arrows there. Okay, what about part B? Where is it increasing?
0 to infinity.
Yep.
Would you put bracket or no?
No, leave it as parentheses.
And you can do parentheses for both, even if it's like filled in.
Yeah, actually, you should. Yeah, actually, if we're filled in, you would put a bracket. Yeah, You would. That's what I'm saying. It is kind of debatable at times, but yeah. But if I said open interval, then you could do 0 to infinity. I'll make sure I'll make that clear. Now decreasing never goes down. And where does it say constant? Right. And technically I should put a bracket around 0 because it does include it. But yeah. Yep, that's all. It's not that hard. So we have some practice problems on that. Okay, let's keep on moving. Okay, relative mins and maxes. Okay. Let me kind of explain the whole tangent line situation again. What if I drew a line like this? And drew another line like this? What would be the slopes of those two lines? Yeah, exactly. So slopes of tangent lines. Slopes of tangent lines at peaks or valleys are 0. So that's how you could tell if it's a relative min or max. That's how you could tell. More specifically, B is a minimum, A is a maximum. What happened, and let me also color code as well. And actually, let me switch this to a more neutral color. Let's go blue. Blue. Okie dokie. The graph was decreasing, and then all of a sudden it started increasing. And then the graph decreased again. So this is very important. You definitely want to add this to your notes. When the graph changes from decrease to increase, we have a min. I copy and paste that. Copy. That stinks. I would copy and paste. When the graph changes from increase to decrease, we have a max. Okay, so hopefully it's intuitive. What's happening on the roller coaster? We're going down, right? And do we hit a low point? Sure, follow them in. Because we start rising, right? Then as I'm rising, what happens after a certain when I get to point A? Do I stop rising and start dropping? Yeah. When those transitions happen, we call those relative mins and maxes. Why do we call it relative? It's not the highest or lowest possible point, because in fact, actually, this graph goes up forever, this graph goes down forever, right? So I want to be careful not calling it like, oh, it's highest or lowest point possible. We actually reserve that and call that absolute mins and maxes. I'm not going to go down that path today, unless it's in the second page or third page. But it's really more about when you see a change from increase to decrease. So the graph is, so it's like a roller coaster, right? Like that's a low point, that's a high point. Maybe the graph keeps going higher, graph keeps going lower. But for a while, it seems like it's lowest, it seems like that's the highest. There's a bunch of other fancy words here, like the function's relative maximum f of f if there exists an open interval containing such an f of a. It seems kind of confusing. What it tries to say is that all the y values close to this is lower than f of a. So that's what makes f of a max. So f of a is higher than all the y values nearby. Here, f of b is lower than all the y values nearby. That's why it's so they call it relative or local, because locally it seems like it's the lowest or highest. I mean, if you want to kind of use a more real life example, yeah, go ahead. Oh yeah, totally. Oh yeah. Yeah, absolutely. Yeah, you could have grab. That's a great question. Thank you for bringing up Talia. Yeah, because what you could have this, right? Totally. Those are all relative max. Those are all relative mins. You can totally have something like that, right? 100%. Yeah, these would be maxes. These would be mins. So this is kind of a fun little exercise. Let's go to Zillow. I love Zillow. Let's go Redwood City homes for sale. So Redwood City, just 10, 15 minutes north of here, right? Redwood City homes for sale. It's actually we're starting to get into that season, and let's sort. Hold on. Oh, I don't want to do that. Well, let me just refresh. Okay, here we go. Oh, there we go. Sort. Duh. Perfect. Good. Okay, so we're not gonna look at the. Okay, so we're not gonna look at an apartment building, but the highest house is on 115. I don't know where Wicker Ranch Court is. This much we need to develop is $4.9 million. So that's the highest house locally in Redwood City. But is it the highest house here on the peninsula? Where do you think the highest house might be for sale on the peninsula? Probably Atherton, right? So this is locally, it seems like that's a max, right? But it's not the absolute highest if you're considering if your domain is like all of the peninsula. So that's what we got to think about domain too. If your domain's Redwood City, it's the highest. But if your domain's a whole peninsula, this might be the highest for maybe Redwood City. But yeah, let's put it's always fun. What are homes going for an Atherton? Oh my god, you gotta be kidding me. Atherton, California. Holy shit. Wow. $50 million. That's crazy. Oh my goodness. Where's this? Park Lane. Yeah. Okay. Okay. Yeah. We drive, it's Park Lane. If you drive on that. Yeah. Yeah. It's just right over here, right? Yeah. Walsh Road. Um, actually, I wonder if that's, close to where, the CEO of Google, he lives on Walsh Road, I think. The CEO of Google. He actually, I used to tutor his daughter. So, anyway, many years ago. Wow. Okay. Anyway, but that would be the absolute maximum, right? So yeah, we're gonna have a lot of fun when we do the home buying project in the spring. It'll be so much fun because you're starting. We'll have time. We'll be able to fit it in. Yeah. So anyway, so that's kind of give an idea of like locally, Redwood City, that one house that was $4.9 million is still kind of crazy. I don't know who has this kind of money just to make it in stock market tech. Anyway, let's keep moving. So let's look at this one here. Approximate 2 decimal places any relative min or maximums for this function here. We'll do a practice one, then we'll talk about even odd functions, and then we'll kind of do a big one there. Okay. So yeah, let's do this. So I'm going to go to and I said sometimes the word local is used in lieu of relative. So let's go to decimal. Let's go to x cubed minus 3x squared. So x cubed minus 3x squared minus x plus 1. And the beauty about decimals, you don't have to type in y equals, but whatever, I'll do it anyway. So let's label these two dots here. Okay, so these two dots here. That first dot I labeled, we would say that's a relative max. It's not the highest possible point. It's not like Atherton. This is Redwood City, right? This I call the relative min. It's not the lowest point, but it seems like it would be the lowest point for a while. And if I get a highlighter out, this is clearly rising. Oh, come on. This is clearly rising. And this is also rising. But then this graph is dropping. So that's why it's a relative max. And the way you write it, you write like this. The function has a relative max of 1.079 at x equals negative 0.0155. So one nice thing about teaching calculus is that I could tell you what you need to do so you're successful in calculus, because I've taught calculus for many years. Here, you would say the function has a relative min of negative 5.079 at x equals, and I'm really going to be kind of a stickler. I want you guys to be successful in calculus. You know, I want you to be formal and kind of sophisticated in the way you write this. Especially if you're in college, college professors will really nail you on this stuff if you're not precise with your language. So you state the y coordinate at x equals. So what's the highest y coordinate? What's the highest output? The highest output is 1.079 at that x coordinate. What's the lowest output for y? Negative 5.79 at that x coordinate. So that's how you have to state it.
It's the not because it
from increase to decreasing, yes. Yeah, that's relative max because it goes from increase to decrease, as it should, right? Because you're going up the roller coaster and down. And again, you're saying the y value here, and this is the min, who's going from decrease to increase. Exactly. That's how you want to think of it. So I want to make sure I'm explaining this properly in the calculus type of terms so that we're clear on it. Okay, we're good? There's one more example, but we could skip it. I think you guys get the point. You'll have a chance to practice in the homework. We'll skip that example. All right, last up, even odd functions. I don't know if you guys covered this in algebra 2. I don't know. An even function is one that's symmetric about the y-axis. An odd function is one that's symmetric about the origin. Also, it looks like this. Actually, let me back up a little bit. Let me give you some example. I'll explain in a sec. Let me write function notation. My apologies. Okay, let me explain. Do you guys cover this in algebra 2? No? Odd even functions? No? Okay. So, symmetric about the y-axis. So that's an odd, sorry, that's an even function. So technically it means f negative x equals f of x. What this means is that the y coordinates are the same, whether you change the sign of x or not. It's the y coordinates stay the same. So y equals x squared. If I plug in 2, I get 4. If I plug in negative 2, I still get 4. If I plug in 3, I get 9. If I plug in negative 3, I still get 9. If I plug in 4, I get 16. If I plug in 4, I still get 16. So there's no change in the y coordinates when you change the sign of x. Y equals x squared, if you graph it, does that y-axis cut in half? You bet. That's a line of symmetry. An odd function is when you switch the sign of x, the sign of y changes. So y equals x cubed, right? If I plug in 2, I get 8. If I put in 8, I get negative 8. Did the sign change here? It did. If that's the only thing that changes is the sign of the output, then we say it's an odd function. So here's y equals x cubed. If I rotate this about the origin, if I rotate 80 degrees about the origin, that's why I say it's about the origin, I get back to the same graph. It's like a spinner, right? If I were to spin it 180 degrees, I get back to the same graph. That's an odd function. It's good to know even odd functions so you can know how these graphs will look and how these graphs behave. So we're going to do some examples right now to help you understand this. Sometimes it'll be neither. If neither of those things happen, if y does change and it changes drastically, not just a sign change, then it's neither. But if y stays the same when you change the sign of x, even. If the signs of y change and that's it, when you change the signs of x, odd. So let's do this right now. Let's look at these here. Let's plug in f of 1. No, so let's do f of 2. F of negative 2. So this is part A, part B, and part C. So let's plug in 2 and negative 2 and see what happens. If I plug in 2 into the first function, what do you get? Not 4. It's at minus x4, right? Yeah. If you plug in 2, the whole thing, what do you get? 4 minus 16, which equals negative 12, right? Does that make sense? Negative 12? What if I plug in negative 2? What do I get? Same thing. Therefore, this is an even function. Okay, what if I plug in 2 to the second one, part B? What do I get? 2? You should get 32 minus 16 plus 2. What does that equal? 18. Now let's plug in negative 2. I get negative 32 plus 16 minus 2. What do I get now? So that's an odd function. Not always true, but it does work for polynomial functions. All the exponents are even in part A. All exponents are odd in part B. That's kind of an interesting observation. Okay, let's plug in 2 into h of x. You get 7, right? But plug in negative 2, you get negative 9. That's neither. Plus, if you're to graph it, it looks like this. Does the y-axis cut that in half? No. If I rotate 180, if we rotate 180, it's going to be here. It's not going to be the same place. Rotate 180. Because also this point here is 0, negative 1. This is going to be at 0 if I rotate 180. So it's not going to happen.
Basically, it has to be the same number, but it's either both negative or both positive, or one's negative.
Right. 100% correct. 100% correct. Yeah, if the y stays the same, like both positive, both negative, it's even. If there's a sign change, it's odd. Okay, let's look at this graph here. So the last thing we'll do, and then we'll be done with the notes today. Okay, there's an arrow. Let me make this clear. There's an arrow here. There's an endpoint here. There's also some sharp corners here. Okay, let's do this one by one. Okay, what's the domain? What did you guys say?
Are those all started with them?
Yeah.
The domain would be negative infinity for the bracket on the side.
Good. What about the range? What's the lowest y value here? There's an arrow pointing down. Yep. And the highest y value is 1. Yes. Okay, the zeros are the x-intercepts. Where y equals 0. Where does that happen? -3 and 3. F is 0. What does that equal? When you plug in 0 for x. Yeah, it's just at 1. Okay. Then let's do this here. The graph is clearly rising. It's clearly dropping here. And it's clearly staying the same here. So where is it increasing from what to what? Negative infinity to -2. Where is it dropping? To infinity. Oh, duh. Wait. No, it starts at 2. Oh, 6. You're right. Yes. Sorry. It goes to 6. Yes. Where's the constant? -2 to 2. Good. Yeah, I know kind of contradicts myself. I said we'll do open intervals. We could keep it closed too. I'm not gonna, honestly, I'm not gonna care. Whether you keep open or closed. Okay, values of x where y is bigger than 0. Well, you want y to be, you want to be above the x-axis. Yep.
And do you just write that like -2?
Yeah, because you can't include them because if you include them, then y would be 0, and you have to be bigger than 0. So you have to be above the x-axis. Okay, where does y equal -2? At what x coordinates does y equal -2? -5 and 5. F of 4 equals -1. So it's clearly negative. K is kind of a tricky one because it doesn't go on forever on the other side. So I'm going to say neither. Even though it does look like the wax cuts in half, I'm going to say neither because the left side is not a mirror image of the right side. And when I say left side of the y-axis. And when I say right side of the y-axis. And then lastly for L, did we change from increasing to decreasing? No, it's a constant, right? So yeah, in this case, is f of 2 relative? Well, that's a tricky one too. Because it does stay constant. I'm gonna say yes. I'm not gonna give you guys ones that are some of these are debatable. I think K and L are pretty debatable. I'm gonna say yes because it was increasing before it got there. So I'm gonna say yes. Then eventually decrease. I'll give you ones that are less debatable, so or more clear. Anthony, go ahead.
Sorry, can you repeat what you wrote down for?
Yeah. Yeah, the explanation, sorry, that's my chicken scratch, right? Because the left side is not a mirror. Yeah, because it's not quite a mirror image because it stops here. If there's an arrow that's going down, then that's a yes. For sure, yes, it's me. Yeah, so anyway, let's go stop there for today. I think we did enough for a Friday afternoon. So I'll end the video. All right.